All right, we're going to talk about system of equations in three variables. Okay, so the amount of variables we have determines how many equations we need to solve this. If I have three variables, I need three equations. If I have five variables, I need five equations. And we're going to use elimination here. So I have the first problem here. I have two problems here. So the first one, I look here and I see that I have x, y, z. I just have to pick one of the variables to eliminate. Okay. Now, if you're looking at this, you probably already noticed that we have y's that are different and z's that are different. So I actually can solve for my x very, very quickly. And so I'm going to go ahead and do that. So I'm actually going to combine these two like right here. So I have x minus 2y plus 3z equals 11. And then I have 4x plus 2y minus 3z equals 4. And when I add these together, I get 5x equals 15 or x equals 3. Okay, so that's the first one. I've solved one of my variables. Now what I'm going to do is, since that eliminated both these here, I need to use this bottom equation here. But I'm going to substitute 3 back in to these equations here and solve. So I end up with 3 minus 2y plus 3z equals 11. And then I have 3 times 3 plus 3y minus z equals 4. And now I'm just going to move these constants over. So I'm going to subtract 3. So I end up with, what happens is this is going to become negative 2y plus 3z equals 8. 3y minus z equals, so this is 9. This gives me negative 5. Now, I need to pick one more variable to eliminate. I notice that my z's are opposite sides. Both of my y's are too. But I only have to multiply the bottom equation by something to eliminate the z's. So what I'm going to do is I'm going to rewrite my top equation, negative 2y plus 3z equals 8. I'm going to multiply the bottom by 3 so I can get rid of the z's. So this gives me 9y minus 3z equals negative 15. All right. So this gives me, so when I add these, now I get 7y equals negative 7, or y equals negative 1. So now I have my x, I have my y. Now to find my z, I'm going to take these, I can take this and plug it right back in here to find my z. So now I have 3 times negative 1 minus z equals negative 5. Negative 3 minus z equals negative 5. Add my 3 over. Negative z equals negative 2, or z equals 2. There's my z, there's my x, my y. Now, when I put these in here, these are going to be ordered triples. So 3, negative 1, 2, that's an ordered triple. Okay? So a lot of times they'll want it in this form, back in this form. So you're going to have to, when you're solving systems of 3 variables and 3 equations, you're going to have to eliminate these out. So let's work out the next one and kind of go through. These are very easy to make a simple computation error on. So be careful when you're working these out. Okay? Now, I need to pick a variable to eliminate in these items here. When we're looking at eliminating them, a lot of times you're just going to have to combine, pick one equation and then combine it to the other 2 equations. Okay? So, for example, I'm going to go ahead and eliminate my y first. So what I'm going to do is I'm going to combine the top and the middle equation, and then I'm going to combine the middle and the bottom equation. So here, to combine the top one, I need to multiply the top by 4. So I end up with 4x plus 4y plus 4z equals 8. The middle row, don't have to do anything with, so it's 6x minus 4y plus 5z equals 31. And then I'm going to combine these. So these, this gives me 10x plus 9z equals 39. Now I'm going to do the same thing on this, the bottom and the middle. So I'm going to rewrite my middle one, 6x minus 4y plus 5z equals 31. I'm going to multiply the bottom by 2. So now I have 10x plus 4y plus 4z equals 26. And now I'm going to combine these. So now I have 16x, the y's go away, 9z equals 57. Okay, so now I have to work with these two. So 10x plus 9z equals 39. 16x plus 9z equals 57. And now I have to eliminate one of these variables. Well, I already have the same coefficient. So what I'm going to do is I'm going to multiply the top by a negative and then combine them. So this is going to give me 6x equals 18. I'm going to divide by 6, x equals 3. So there's my first variable. Now what I'm going to do is I'm going to solve one of these for z. So I'm going to take this equation, 10 times 3 plus 9, z equals 39. So this gives me 30 plus 9, z equals 39. Subtract off my 30. 9z equals 9, or z equals 1. Now I have x, I have z, I need to find y. So I'm going to go back to my original equations here. Doesn't matter which one you pick, just pick one. I'm going to pick the easier one, so I'm going to go x plus y plus z. So I'm going to go 3 plus y plus 1 equals 2. So y plus 4 equals 2. Subtract off my 4. Y equals negative 2. Now if I'm going to put this in ordered triple, I would have 3, negative 2, 1. There's my ordered triple. So when you're working on these systems of equations in 3 variables, make sure that you're going to have to use elimination. It's just be careful on your multiplication, your addition. Make sure you write down the problem correctly. And that's kind of how we're going to handle systems with more than 2 variables. If we have 3, 4, 5, 6, 10, it doesn't really matter. We're going to do that same process of elimination.